what is the land is reduced up to the some of the also reducing the standard weapons that amount of but if you have stories amount of provided to the driver over the period of time, almost 3 seasons in the week, the land becomes visible cultivation instead of the active land creation. Okay, so physical cultivation uses the all types of crops. So it is not this plain land. The little process is done daily agriculture is done, then it is not plain land. Also, then taking parameters like balance type, so this can and already makes it perfect. Okay, so since we will schedule have a next right, this one is also filled with this water here. So in order to maintain equilibrium elimination of this reduced gas air and the gas even better increase in its salinity, the amount of water added to this provide there is a effective way in this amount of water is and which is required. This amount of water is needed. Using requirement, you have to also do in the first factor that is efficiency and the user water. So, Kerala, listing requirements. So, water listing requirements are requirements. Having interesting physical water is not nearly divided for water This is the dry layer. This is the layer. This is the prime cell. This is the water applied. And this water is thoroughly and the food and reduces the water phase applied without water, here is the water applied for irrigation purposes. Also we can write utility vector water equal to zero minus 2. So we can write scalar equal to 0 minus 2 okay. So rating requirements are also with expressed in terms of concentration of salt in irrigation water and also explain about the water that is in terms of reduce. So we can also write in terms of efficiency. will bring a sufficiency to so by this relation, with the help of this relation, we can solve both the derivative. So write the question. Question is, estimate the data that is adapted equal to 1 upon 3 subject when each value of the derivative that by 2 micromolar and 20,000 and what is the required use of water to supply to the field if yield of crop is given? Then what will be the required to apply to the school? Obviously, this first of all, the private statement that you have to write the relation of data,
so how we calculate? So how we calculate? So we can write LR equal to dD by di, depth of water by amount of water that is supplied for irrigation equal to ECI divided by 2 ECS. So ECI and ECS value is given. ECS is the 2 times of ECI. So ECI value is given 1.2 and ECS value is given 2 into 10. So this is the LR is the 6%. LR is the 6%. So amount of water required for reaching is the 6% of total supplied of water. Again, we can calculate LR equal to dt by di equal to di minus a divided by di. So LR given 6%, di is di in terms of di, Cu is given 80 mm, and here also di equal 100. So by solving this relation, we find that depth of irrigation water equal to 85.10 mm. Okay, 85.10 mm. So in order to avoid water logging drainage system is to be provided, and this system is of two types. First is the surface drainage, second is the subsurface drainage. So for surface drainage, it is removal of two types of system is provided. Drainage system is provided. So first is the surface drainage. Surface drainage. Second is the subsurface drainage. Okay. So surface drainage, it is the removal of excess water falling on the field or excess irrigation water applied to the field by use of open ditches or drains. Okay, that is the aim of the surface. Aim of the surface removal of water method. So surface drain are two types. First is the shallow. This surface drain is also two types. First is the shallow surface drain. Shallow surface drain. Second is the deep surface drain. Deep surface drain, also called French drain. French drain. So shallow surface drain collects the water from surface, whereas deep surface drain utilizes subsurface water also from the tiles drain. So next is about subsurface drainage system. Subsurface drainage system. So these are the drains required for the soil with poor internal drainage and high water table level. So subsurface drain or tile drain offers several advantages over the surface drain. So first advantage is increases air circulation, reduces the soil erosion, also reduce interference with cultivation operation. Also it permit deeper root zone, hence the higher yield gives. These are the advantage of surface and subsurface drainage system. So next we have to study about design analysis of tile drain. Design analysis of tile drains. So tile drains are usually made up of porous material, okay, made of porous earthware in perpendicular section, and the phi of this drain, the dia of this drain is varies from 10 centimeter to 30 centimeter. So minimum dia range is 10 to 15 centimeter. This is also drainage system porous earthenware, and phi, that is the dia of drain. Dia of drain range is 10 to 30 centimeter, but generally the minimum range of dia should be 10 to 15 centimeter dia. So these are laid on certain longitudinal slope varying 0.05 to 3% slope, and the closed drain are generally spaced at such a distance as to be capable to lower the water table level, and also sufficiently below the root zone of plant. And also for most of the plant, the top point of water table must be at least 1 to 1.5 meter below the ground level table, and this level is varies from plant to plant also up to 0.7 to something 0.7 to 2.5 meter. So the tile drain may be placed at amount 0.3 meter below the desired highest level of water table, and as far as possible, these drains should not be placed below less pervious soil material, as is in that case it may remain dry even in the soil also available in waterlogged condition. So in such a case, if drain are to be provided, it must be surrounded by graded filter or envelope filter having minimum thickness of 7.5 centimeter. So minimum thickness should be 7.5 centimeters. So tile drain is just like this is the soil thickness of 10 centimeter, and here is a drainage provide, and this drainage is the tile drainage. This is the soil. Okay, and at this level water table is available. At this level water table is present. So this is the line diagram of tile drain system. Also provide tile drain with graded filter. So see the diagram of tile drain with graded filter. So this is a just like here is a provider drain. Tile drain is provided here, and also some grade is provided. Some graded stone is provided, and here is the soil layer. This is the water table. This is the water table level. So this represent line diagram of tile drain with graded filter. With graded filter. Okay. So the water drained by the tile drain is discharged into some bigger drain called deep surface drain. And the water from the tile drain may be discharged into an outlet drain by gravity or by pumping. So we can also see this system by diagram. This is the system. Okay. This is the water table level. This is the tile drain is here. Tile drain is here. We can also see the outlet drain. This is the outlet drain. So water table level is here. This is the ground level. This is the ground level. This is the surface layer, bottom layer, and here is the tile drain. So fronate form in this way. In this way, fronate is formed. This is the flow line. This green line is the flow line. This is the flow line. This is the tile drain. And this this level is the water table level after drawdown. Water table level after drawdown. So in base level, this figure can see as this is the ground level. Ground level is shown by this mark. This is the water table level. Here water table is present. Root zone is here. Root zone is here. So here drain is provided. Here drainage provided. This is the water table fluctuation after the drain. So let S be the spacing between drain and A is the depth of impervious stratum from center to drain. Then the maximum height of drain water table above the impervious layer is V. So we can share this diagram. This is the root zone, water table level. This is the ground level below the surface. Drainage available here and here. So water table move from this to this. This length is S. This is this distance. This central distance is D. Fluctuation level is Y. This fluctuation level is 5. Here also water table. This represent water table fluctuation. So this height may be 0.3. This is the A. This is the B. So the length of tile drain can be calculated as Qx equal to Ax Bx, where A area equal to y into 1 for unit length, V equal to Ki, that is I equal to hydraulic gradient, K is the permeability according to Darcy law. So Qx in x direction, we can also write y into 1 K into dy by ds. So we assume ds by dx, then Qx equal to K into dy by dx into y, that is equation 1, and at x equal to s by 2, at x equal to s by 2, Qx equal to 0 by this equation, and also at x equal to 0, Qx equal to Q by 2. Then assuming Q is inversely proportional to the distance from the center to center drain, in that condition, Qx equal to Q by 2 minus Q by 2 into X by S by 2. Then we can also write Qx equal to Q by 2 into 1 minus 2x by S equal to 2 by 2s s minus 2x. This is equation 2. So again we can write Qx again we can write x in terms of permeability constant k into dy by dx into y equal to q by 2s into s minus 2x, and it integrate to the limit a to b k y dy equal to q by 2s 0 to s by 2 s minus 2x into dx. Then we get the value of s, that is 4k by q b square minus a square. So this is the value of s. So if the value of total discharge to be carried by the tile drain is taken equal to 1% of average annual rainfall, then drain in 24 hours, and this is termed as drainage coefficient. This is termed as drainage coefficient. So on basis of this formula, S equal to 4K divided by Q into V square minus A square, we can solve different types of question of tile design of tile drain. So write a question of tile drain design. Question is, in a tile drainage system, the drain are laid where the drain are laid within the center between 1.5 meter below the GL and the impervious layer 9 meter of ground level, and annual average rainfall in this area is 80 centimeter. If 1% of annual rainfall is to be drained in 24 hours to keep the highest position of water table to 1 meter below the ground level. So determine the spacing of drain pipe. If K is given 0.01 centimeter per second. So according to this question, given information is drainage system of the drain are laid within the center below the depth is given 1.5 meter below the ground level, that is D is given, and also given information is impervious layer of 9 meter ground level, and annual average rainfall is B equal to 9 meter. Rainfall equal to 80 centimeter, and 1% of annual rainfall is to be drained in 24 hours. So water table position should be 1 meter below of the ground level table. In that condition, we have to find the value of S. So what is the formula of S? So S equal to 4K by Q into B square minus A square. So B is given 9 meter. So 9 minus 1, that is 8 meter. And also A can be calculated, 9 minus 1.5, that is 7.5 meter. Discharge we can calculate by K into I. 80 centimeter rainfall is given, and 1% of total rainfall discharge is maintain the groundwater table in 24 hours. So we have to find the value of S. So with the help of formula S equal to 4K divided by Q into B square minus A square, we can find the value of S. So put the value of A and B and Q. K is also given 0.01 centimeter per hour, and calculate the value of S. So S value is approximately 183.5 centimeter. That is 1.8 meter. This gives the spacing between two tile drains. Spacing between two tile drains